Welcome everybody to today's AMPC webinar on working with hydrogen, applications for red meat processor stationary energy. I begin this afternoon by acknowledging the Gadigal people, traditional custodians of the land from which I'm presenting, and I pay my respects to their elders past, present and future. Today, our presenter and project provider is Clint Butler from Pure Hydrogen, and I'll introduce Clint in a short moment. To give you some background, AMPC has a strategic plan for 2025, and as you know, we also have a CN30 target for the whole of the red meat industry, which requires red meat processors to move away from fossil fuel energy. And under our sustainability goal number 7, we're looking to achieve 5 feasible alternatives to fossil fuels by 2025. And those 5, we feel, the first one being solar PV and solar thermal, which is well underway. Next is biogas and biomass. We're having some success with those. Number 4 on our list is hydrogen, which we'll talk about today. And number 5 on the list is alternative waste to energy and storage technologies. Next. So our hydrogen pathway commenced in 2020 with our renewable hydrogen cost benefit analysis for Australian red meat processors. We conducted workshops and feasibility studies for renewable H2 production at red meat processing plants. And that process discovered a few things that helped us develop our pathway on hydrogen. First of all, production of renewable hydrogen wasn't considered feasible by processors at that time, given the significant capital and management costs associated with the technology array around production of hydrogen. And that technology array is not just one item, but includes things like electrolyzers, a solar farm, water pre-treatment, compressors and storage. Second, on our pathway, we realised that there may now be feasible alternatives for purchased hydrogen used in hydrogen gensets to replace on-plant diesel or offset peak tariffs in applications such as irrigation pumps, pond aeration, uninterruptible power supply, peak shaving, and 5G towers. Third, on our pathway to hydrogen, in the medium term, we realised that purchased hydrogen for use in heavy fuel cell electric vehicles requires our sector to establish more reliable representative heavy transport baselines prior to any ADR compliant design and cost benefit analysis for those transport options. So today we're talking about applications for red meat processor stationary energy using hydrogen, and I'd like to hand over to Clint Butler from Pure Hydrogen. Thanks, Clint.
Thanks, Matt, and thanks again for AMPC for organising this webinar today. So Pure Hydrogen, in a summary, I suppose we're made up of 3 different parts of our business: technology, looking at fuel cell technology, but also in manufacturing of hydrogen via different manufacturing techniques. We also, part of our business is in the operation side of things. So not only are we producing hydrogen, we're also looking at the distribution delivery, and then also refueling. Pure Hydrogen has a couple of domestic projects underway, and also looking at international projects as well. And then thirdly is our mobility and power generation. So as you can see from the couple of pictures there, we've got a hydrogen ute, which should be on the market by 4th quarter 2022, so the end of this year. We'll have a hydrogen fuel cell ute, a 6x4 prime mover, and a hydrogen generator, and that's what we want to talk about today. Hydrogen, I suppose, is similar to natural gas from or LPG as a handling and as a safety perspective. Hydrogen has a high specific energy, making it very efficient when used in fuel cells for transport, buildings and power generation. Majority of hydrogen used today is a grey hydrogen. It's used in industries such as oil refining, ammonia production, steel production, and the like. There are significant potentials for emission reductions, and that's where we believe Pure's cleaner hydrogen manufacturing methods will come into play. So I suppose the three types of hydrogen that Pure Hydrogen is looking at are green, turquoise, and emerald. There seems to be a different colour on the colour spectrum every day of the week, but these are three that Pure Hydrogen are looking at. So green being more so around electrolysis via solar and wind and renewable electricity. Turquoise hydrogen produced from methane via methane pyrolysis, and from that being methane CH4, you'll have carbon and hydrogen atoms, and so the hydrogen gets split onto one side, and the carbon comes out as a carbon black, and can be used for different applications from that carbon black to be made into graphene is something that we're researching and developing at the moment. And last but not least, emerald hydrogen, which we believe is greener than green, and it's produced by waste to hydrogen using biomass or woody biomass and heat. This is a little bit of a snapshot of Pure Hydrogen's roadmap of where we see ourselves probably over the next 5 to 10 years. As you can see there, we've followed pretty much the east coast of Australia, but also there's an opportunity via the turquoise hydrogen to look at natural gas networks. Anywhere there's a natural gas network, a turquoise hydrogen plant can be placed, and that can be anything from 500 kilos per day, up to 10,000 kilos per day. What do we want to talk about today? The Pure Hydrogen H2 generator. So we're looking at a 100 kilowatt generator, with a gas consumption of about just over 5 kilos per hour. The beauty of this appliance is the only emission is a water vapor. Some various storage methods that we have in place. So initially we'll start with a tube trailer and going to site and leaving the tube trailer on site, and that would run your fuel cell. But certain things in the near future are hydrogen pods. So this one in particular, on the bottom is 500 kilos. That's a 20-foot pod. One up on the prime mover is a 1,000 kilo pod, and we've also got coming very soon is a mobile refueler with the pod that actually comes off, and you can do refueling on site. So whether or not you had trucks or forklifts on site, that can be another option, as well as using that hydrogen for your power generation. So the pilot project, I suppose the description of this project is that we want to scope, design and demonstrate hydrogen applications for alternate use for stationary power generation via the fuel cell. We want to illustrate the feasible pathways for economic and environmental benefits, and make recommendations and provide the red meat processors hands-on experience with a hydrogen fuel cell device. So not only do we want this to work, but we also want to be able to, in the future, look at the red meat processors facilities and look at what other opportunities they may have. The methodology is a expression of interest to shortlist the AMPC's interest in hosting a 100 kilowatt fuel cell. Hydrogen will be generated in an industrial facility. It'll be trucked to the host site as a compressed gas and stored in a hydrogen storage vessel for use in that fuel cell. Outputs and deliverables. So what will we get out of this? So working with RMP host sites to explain the technology, knowledge sharing during pilot site tours, live webinars, open days and video blogs. Creation of a handbook for hydrogen with lookup tables and recommendations for processes for the whole industry, and the scaling of hydrogen fuel cell technology to meet the industry needs. and finally having that final report. Hydrogen opportunities for the red meat processors. So as Matt alluded to earlier, it's that uninterrupted power supply with being your servers, critical comms, 5G towers, emergency lighting, peak shaving for stationary power, edge of plant power, so your irrigation pumps and pond aeration. But our core project is the stationary power via a hydrogen fuel cell generator. There is no cost for the hydrogen or the hydrogen fuel cell. All that there would be is a contribution towards the power tie-in if that's what is needed. And for the future, full off-grid heat and power cogen, and to also look at long-haul cattle trucks, semi-trailers, and forklifts used on site. The motivation behind all of this is zero greenhouse gas emissions for power, cogen, forklifts, and trucks. Emissions intensity dropping, but it's not fast enough for carbon neutrality by 2020. The stretch targets are cost parity with diesel gensets, batteries including mobility, and then grid power. And the goal is to contribute towards zero emissions by 2030 and have 100% renewable electricity by 2030, which from our point of view, that's sort of the path that that we're wanting to lead people down. The cost of traditional power is rising. So the grid, historical high levels, we're seeing plus 100% increases in 12 months, with the default market offering peak at 55.5 cents per kilowatt hour in New South Wales and Queensland. Diesel gensets, 60 cents per kilowatt hour just for fuel, excluding maintenance and capex. Batteries at 20 cents per kilowatt hour at scale to plus or minus 40 cents per kilowatt for a household size system for 100% daily utilization. And hydrogen, well, it achieves diesel parity at approximately $14 a kilo, assuming diesel stays at $1.90 a litre after ATO rebate. So, you know, if I'm a betting man, I probably I wouldn't be betting that it's going to stay at $1.90 a litre. Advantages of no emissions and silent operations. AMPC supports this trial as an update of hydrogen expected to be rapid as hydrogen fuel cell capex plummets and large-scale hydrogen production comes online. So the more fuel cells that we get out into the market, that drives the cost of fuel cells down. But also, likewise with the hydrogen production at larger scale, and the more production that we do, will drive the price of hydrogen down. All right, thanks, Matt.
Hang on, Clint. There's a lightning quick presentation. Got me off guard there. We've got a couple of questions, and one comes from WA. Obviously, any plans for expansion to WA? One of the questions.
I think with pure hydrogen being a national corporation, yes, there probably will be a move into WA. There's a little bit of stuff being done in WA currently, not with pure hydrogen, but that's not to say that we don't have partners over in WA that we can source hydrogen from and do something similar.
Right.
At the moment, pure hydrogen is currently focusing on the East Coast. I suppose that's where a lot of population for Australia sits at this current time.
Yep, thanks, mate. That makes sense. So we've got a couple of emails that relate to the presentation. So the first one is: can hydrogen be used in in combustion generators? Would it save fuel and cost?
Yes. To answer that, yes, hydrogen can be used in a internal combustion engine. There's a couple of different companies around Australia that are currently doing it. But the maximum that they're saying that they will save is about 40%. Is about 20 to 30% on your diesel costs. So yes, it can be done, but I suppose in the scheme of things, it is a little bit of a stopgap. But you know, for some businesses, it can be a first step.
Right. That's interesting, Clint. But I'd remind everyone on today's webinar that this project, this pilot project, will supply the hydrogen and the genset to 2 plants to trial at their premises in regards to production of power. So it's rather than for combustion, it's really for power, isn't it? So, but
Correct.
That's a good question. Nevertheless, it's a good question, isn't it? Because the idea is that we're trying to unearth and we're trying to uncover as many applications for hydrogen that we can, particularly for purchased hydrogen, because the price is, you know, looking better as time progresses. And so any members that, you know, with those sort of interests should still ask the question for applications that are not covered by this project, such as forklifts and combustion engines and those sorts of things, that no doubt pure hydrogen could deal with those questions as well during the project.
I might add, Matt, that we talk to a lot of people in the agricultural industry, and you know, they're probably getting hit the hardest with diesel costs at the moment, and rising LPG and natural gas costs, but more so for their irrigators on their farms. You know, being a stationary engine or a stationary fuel cell or engine, you know, likewise, it's something that hydrogen can be used as an alternate, but also as a substitution. And yeah, we're getting a lot of queries from a lot of people in that farming agricultural sector,
Yeah,
that are looking at, you know, yes, they may not be able to afford a hydrogen fuel cell generator, you know, off the bat. Is there a something that they can ease into by you know, maybe doing 20%, to at least make some sort of saving based on what their current diesel prices are, you know? And I suppose something from that is pure hydrogen does look at a wet lease on all of our equipment. So whether it's generators or trucks or forklifts or buses, and what we can say from there is that we can have a fixed cost on our hydrogen supply. So, you know, if we look at either a 5, a 7, or a 10-year deal, we can actually fix the hydrogen price for that amount of time. And I think that's something that's becoming more beneficial now, considering the ups and downs of where diesel's sitting, and I suppose having that security of supply. By, you know, 90% of Australia's diesel comes from overseas. When we had all of the AdBlue issues at the start of the year, you know, it was getting a little bit worried that you know, we weren't going to have trucks on the road. So, you know, having a surety of supply here in Australia, I think that's very important to pure hydrogen as well, as our customers.
Yeah, thanks, Clint. Another question here, someone that's interested in the pilot with more detail in the pilot plant. What is the footprint of the pilot plant? Can you describe that and the items that make up that footprint?
Yeah, okay. So the footprint would be so hydrogen storage at this current time would be a 40-foot tube trailer. That holds about 350 kilos of hydrogen. The actual generator is tiny. It's 1200 by 1200 by 1200, so it doesn't take up a very big footprint at all. The only consideration with that is we need ventilation for that generator, and then like LPG and natural gas, having the right exclusion zones around that hydrogen supply and the hydrogen generator. Does that answer that question?
Yeah, I think that answers that question pretty well. I mean, what we can do as we get into the expression of interest stage, of course, and further beyond, we would be providing a diagram and an illustration of the footprint for members so they can understand where it fits and how it ties in to plant infrastructure.
Yeah, that's correct.
Yep. So I mean, a fuel cell generator at 100 kilowatts he's not going to have the footprint of a solar PV system at 100 kilowatts, is it? Very, very much smaller.
Yeah, that's right. That's right. And
yep.
you know, and the 40-foot tube trailer, well, we're looking to even bring that down, you know, 500 kilos at in a 20-foot container, which will be more modular as well. So it can be either added to or taken away.
Thanks for that. Another question came in via email. Someone's interested in the pilot project from the perspective, how does the refueling and the distribution work from the storage tanks? I guess that question is asking if there's someone is involved in the pilot and you've got hydrogen storage on site, can it be accessed for things other than the genset?
Yeah, most definitely. I think that's the goal. You know, is once more of the processing plants look into what else they can utilize hydrogen for. Yeah, you would have a centralized hydrogen storage area, and you would have pipe work coming out of that. So yeah, so for that instance, yes, you could have hydrogen coming off the tube trailer for the generator, but you could also have I'll just jump up to it because it's easier to explain, but this one here. So this is a hydrogen mobile refueler. So this actually pod comes off the truck. It's on hydraulic legs. Hydraulic legs come down to the ground, and you've got a refueler at the back of it. Now that could be used. That could be hooked up to a generator, as well as having forklifts come and refuel off it as well. It's got telemetry on there, so we know exactly how much volume's being used, and when it gets down to a certain limit before it either needs to be exchanged or topped up.
Very good. Thanks for that. Just another question on the, I think you've already mentioned this. This question talks about hydrogen as a service, not for acquisition. I think you mentioned the wet hire approach. Have you got any examples of how that might work? Yeah,
so we've currently signed a deal with JJ Richards for waste collection. So we're providing a waste collection truck to JJ Richards. They will, so to put it out there, a waste collection truck currently, diesel on the road, ready to go, is about $400,000. When I first went to JJ Richards and said, hey, listen, we've got a hydrogen truck for you, the price is $750,000. You know, they balked at it and said that's not going to happen. You know, it's too expensive. So when we broke it down to total cost of ownership and actually said, well, rightio, well, let's break it down over a 7-year period. You'll have a fixed monthly cost, and that monthly cost will incorporate the price of the truck or the lease of the truck, the hydrogen, the distribution, and the refueling. And once that was bought into a monthly rate over that 7 years, the total cost of ownership actually came down below what the diesel, what they were paying for their diesel truck over that 7-year period. And the other thing that they had said is, one, okay, the diesel truck isn't zero emission, so there's a tick. And two, we don't know what the price of diesel is going to be, you know, in 3 months' time, 6 years' time, and we definitely don't know what it's going to be in 7 years' time. So having a fixed price, their CFO was pretty pleased to know that was on the table.
Yeah, that's really interesting, because that would mean that what you're providing here, and this is outside the scope of the pilot, but your wet hire example, essentially you can provide a power purchase agreement based on hydrogen, renewable power purchase agreement.
Yeah, that's right. Yep, that's correct.
Behind the meter renewable power purchase agreement, which I don't think there's anything like that really at the moment. So that's one of the things that, and why would you pick 7 years, Clint, in terms of that agreement?
7 years. So yeah, so the reason we pick 7 years, that's the magic number. Because 8 years is normally the life of a fuel cell. So after 8 years, that fuel cell will start to degrade and lose power. So what we normally do after 7 years, we take that out, refurbish that fuel cell, and then it can go back out as brand new.
Right. Okay.
So I suppose to explain the fuel cell a little bit more, because some people might be sitting there going, well, what the bloody hell's a fuel cell? So a fuel cell is it's what makes the hydrogen. So you have hydrogen storage goes through the fuel cell. So it's a chemical reaction from that, but going through the fuel cell, the hydrogen turns into electricity, and then that electricity then can be used for, for whatever it needs to be used for.
Yeah, that's good. Thanks, Clint. And while you were describing that, someone's put another question, which is a good segue to flexibility in generation and peak shaving of spot, peak prices or spot energy prices. So that the question is the fuel cell generator able to flex generation based on spot energy prices whilst the scale of economy for H2 expands? So
well, I couldn't see why not. I think it's a great idea, and peak shaving, I think you would take full advantage of it. You would just have to work out with your retailer, depending on what times that your peak power is getting charged at, and then look at what you could do with the generator during those peak hours to bring that, to do that peak shaving.
Yep.
I think it's a great idea to do something like that.
I'm assuming it'd just need an energy management system.
Yeah, correct.
Yep. To analyze those prices and when it comes on and off. Is there a ramp up or anything like that? It's pretty.
Not that I know of, but yeah, I suppose that's something that we can definitely answer that question, but probably not myself. But yeah, I can get one of my colleagues to answer that.
Yeah, that's a good question, and it shows that there's definitely some interest here. The project, the idea of the pilot project is to answer these questions during the project. So there'll be these sorts of queries that come up. We realise, we need an energy management system with this genset for it to be smart, so we can handle peak shaving, spot prices, perhaps demand response. But the intention is to develop a list of tasks that the H2 genset can be assigned to, and develop those tasks, and then have them sequenced, I guess, so that they're not all tasks at the same time of the day, but this genset can have a series of tasks at a red meat processor plant to fill up its workload and to make it more productive, make the business case more attractive, and of course reduce emissions. That's what it's about, isn't it?
That's what it's about, yeah.
Just getting some more questions here. Are there any byproducts in the generation process?
The only byproduct is water.
Very good. Yep. And I wouldn't imagine there'd be
probably not enough water. Probably not enough water to be used back into the business.
Yep.
But yeah, all the same. Yeah, it's pure water. Might be able to have a water fountain.
No emissions, Clint. Eh? No, there's no emissions. Yep.
That's right.
I don't know how you'll answer this one. It's part of the reason why we're doing the project, but I'll read it out anyway because it's a question. Where is H2 pricing now, and in the short term, Question mark.
Okay, yeah, that's a good question, because you know, the price of hydrogen overseas and in Australia, a lot of people talk about $2 a kilo for hydrogen, and I laugh every time I hear that. The government says it all the time, and I think to myself, you know, the government just doesn't understand the price of the infrastructure that has to go in play to make hydrogen, and then the distribution side of it. So with $2 a kilo for hydrogen, I would probably see, if I was to forecast, I would probably see that, you know, being mid to late 2030s for the price of hydrogen to get down to that sort of price. Currently, if you were to buy hydrogen, you would be paying anywhere from $17 a kilo up to $65 a kilo, depending on what location you were. Overseas, in America at the moment, in California, you pay about $16 US a kilo. Pure hydrogen's pricing is about $14 a kilo. But as we say, at scale, that pricing can come down, and you know, we probably see that forecasting in the next couple of years to get down as low as $8 to $9 a kilo, so under $10.
That's encouraging. Yeah, that's really encouraging. So, you know, this is something made in Australia, where the energy source is produced in Australia, and it's offsetting an energy source that's not made in Australia and is highly variable in the future. So it's logical.
Yeah, and I think also, just from that, Matt, you know, if we're looking at $14 a kilo now, and that's near diesel parity or just below diesel parity, you know, if the price of diesel keeps going up, that's when it gets down below $10 a kilo. You know, it's starting to look very, very good. Not only are you saving money, but then you're also, you know, you look at your emission savings, and you know, and I think that's the game that we're in at the moment, is trying to do that, getting businesses and Australians down to net zero.
Yeah, that's right. Another comment and a question here for you, Clint. The flexibility of the H2 genset sounds fantastic. Is it mobile?
Not at this stage. We are working with the gas regulators for approval on that, but at the moment it's considered as a Type B appliance, so it's got to be stationary. So, for example, if I was on a site and we were using it for a pond aerator, for instance, and we had to move it from there to another pond, you'd have to get a different approval every time you moved it. So at the moment, it is considered as a stationary appliance and not mobile, but it is something that we're working on, especially. So pure hydrogen has 4 different size generators, so a 5 kilowatt, a 20, a 50, and 100. So the 5 kilowatt ones are definitely good for the construction and building industry. And that's something that we sort of had in our plans, that we were going to use that as a mobile site that they could use on construction sites. But yeah, it got knocked on the head. It's only because they don't know how these things work at this point in time. But you know, after we have these case studies and these trials, you know, then the gas inspectorate will be more and more over it, and you know, will adapt to it. So yeah, so stay tuned for the mobility within generators. I think it will happen. It's just a matter of how long.
Yeah, good point. So that's another reason why we're doing this pilot, is so we can talk to the authorities about what it's capable of and what we need it to do in the future. So we're sort of running out of questions here now. And that's been a really good process, those questions. A lot of focus on the flexibility of the device and the fact that it brings certainty around future pricing with your fixed price scenario you were talking about, and emissions reduction as well. So let's go to the expressions of interest for the project and talk about that. I think that's the next slide, is it?
Yep.
So as we mentioned, that this is a pilot project that Pure Hydrogen is running for us. They're the provider of the technology, and they'll be managing the project. It's a core project, so there's no requirement for financial support from members directly for any of the capital costs or the cost of the hydrogen supplied. There may be some time and effort required by participants in terms of allowing the site location to be identified and assessed, and also the tie-ins of the power output to the plant. But that is a bit of an unknown, because the project still has to work out who the participants are and what those tasks will be for the pilot project. So until we know that, we really can't, we really don't know what the tie-in aspects will cost. So our expression of interest will go out in the next few weeks. It'll ask a few questions. There'll be a scoring process, of course, so that Pure Hydrogen will score the EOIs when they come in, and there'll be some questions to answer. So the first one there: are you able to receive and have parked on site a 40-foot hydrogen tube trailer in close proximity to a suitable power load, i.e. a switchboard or other power load? Please provide details, kVA load, photos of switchboard, load and general surrounding area. So that, as you'd expect, those details will have to be assessed to see which of the applicants expressing their interest are more suited to this pilot project. Then there'll be another question on third-party visitors, because you know, the budget for this is covering two plants. We'd like to see if there are any other members in close proximity that don't have the benefit of the pilot, who can attend and observe and look at, inspect the device while it's operating. So, and there'll also be some service providers needed to access the site for site tie-ins and those sort of things. So the question will ask third-party visitors, can they attend the site for H2 delivery and fuel cell maintenance and inspection? They're really the two main questions. And then there's a weighting of those answers. And as I mentioned, Pure Hydrogen will score the answers. The weighting will depend on three things. There's a weighting on proximity to source of green energy. And what we mean there is that Pure Hydrogen has access to a number of locations for hydrogen supply. And as Clint was mentioning, there's an array of different colours. And I need that guide again to go through those, Clint, because I can't remember them all, but there'll be a preference towards green hydrogen for obvious reasons. This is about emissions reduction as well as anything else. And Clint will be able to answer questions offline during the EOI process around locations of green energy, of green hydrogen. There'll be a weighting towards on-site infrastructure. So plants will be weighted according to whether they can host a fuel cell, particularly of the size we're talking about, 100 kilowatts, in terms of the switchboard and different power load modes such as island mode, etc. And the final weighting will be on whether the applicants have participated in the 2020 or the 2022 Environmental Performance Review. We always put that in there because that's the flagship report we do. And incidentally, this project, if it's successful, will help improve the performance environmentally of the sector. So there's a reason why that weighting is attached there as well. So the EIO process will be in a couple of weeks, and that's what it'll look like. I'm just going back to see if there's any more questions here. Clint, if you can bear with me for a second. Yep. There's one more question. What are consumable components in the fuel cell?
Consumable components.
I assume that means that things you need to replace regularly.
So the biggest biggest expense that you will have for maintenance on a fuel cell is changing a filter, an air filter. That's your only maintenance. So because it's pretty much a fuel cell in a compressor. The fuel cell and a compressor. And so yeah, your biggest maintenance cost is changing an air filter. And I think the preferred maintenance is 2,000 hours to change air filters, or an annual maintenance, whichever comes first. So
Right.
they are pretty neat little appliance that doesn't need a lot of maintenance. But as I say, it's we do want the generator to go into an area where there is good ventilation. So whether or not that's in a room with mechanical ventilation, or electrical ventilation, or outdoors where there's plenty of cross ventilation.
Yeah. So not many consumables, just that 7-year overhaul. That's the main cost.
That's right. Yep.
And of course, you've got that wet hire scenario, which is not, I mean, this project is not the wet hire. We're funding it as core project, but otherwise, outside this project, you've got the wet hire scenario. So you've got all bases covered as far as how people pay for it.
Yep.
Another question there. So a lot of interest and some good questions here, which may well be another plant application that we didn't consider, Clint. Could this be tied to an RO plant to help reduce the footprint of water recycling emissions? I like that question.
Yes, I think that's a great application, and I think that could be that could definitely be something that a hydrogen fuel cell could be useful. Most definitely.
That is a really good question, because often what we're finding with our water recycling pilot, another project, is that it's not always a massive RO or recycling treatment that's needed. It could be a very select RO treatment for a smaller stream, problematic stream, a stream of water, wastewater, that's on the fringe of a plant, perhaps, around ponds, etc. So that brings up the question there, Clint, around tasks, allocating tasks for this pilot. So if there's a number of tasks around wastewater treatment in the pond aeration, irrigation pumps, RO operation, we're starting to build up that picture of all the tasks that this pilot can do. It makes it more effective in terms of the economics. So that's another good question, and highlights the questions that this project is looking at, and wants to uncover those other types of tasks that are suitable for this pilot.
100%.
So some really good questions there today. I think we've covered a fair bit, which is good. Thanks for your time, Clint, in going through the the working with hydrogen presentation, and also explaining the pilot project. EOIs will be open in a couple of weeks, be sent out to members, and we'll look forward to more questions and feedback at that time, or if there's any short answers or questions now, please feel free to send them into the email addresses you have. And otherwise, we'll give you 15 minutes back in your day, and thank Clint for his time, and we'll say goodbye.
Excellent.
Thank you.
Thanks, Matt. Thanks, AMPC. Thanks, members.